For the first time ever, U.S. scientists at the National Ignition Facility at the Lawrence Livermore National Laboratory in California successfully produced a nuclear fusion reaction resulting in a net energy gain. The U.S. Department of Energy is expected to officially announce the breakthrough Tuesday. The result of the experiment would be a massive step in a decades-long quest to unleash an infinite source of clean energy that could help end dependence on fossil fuels. Researchers for decades have attempted to recreate nuclear fusion, replicating the fusion that powers the sun. U.S. Energy Secretary Jennifer Granholm will make an announcement Tuesday on a major scientific breakthrough, the department announced Sunday. The breakthrough was first reported by the Financial Times. Nuclear fusion happens when two or more atoms are fused into one larger one, a process that generates a massive amount of energy as heat. Unlike nuclear fission that powers electricity all over the world, it doesn't generate long-lived radioactive waste. Scientists across the globe have been inching toward the breakthrough, using different methods to try to achieve the same goal. The National Ignition Facility project creates energy from nuclear fusion by what's known as thermonuclear inertial fusion. In practice, U.S. scientists fire pellets that contain a hydrogen fuel into an array of nearly 200 lasers, essentially creating a series of extremely fast, repeated explosions at the rate of 50 times per second. The energy collected from the neutrons and alpha particles is extracted as heat, and that heat holds the key to producing energy. They contain the fusion reaction by bombarding the outside with lasers, Tony Rollstone, a fusion expert from the University of Cambridge's Department of Engineering, told CNN. They heat up the outside, that creates a shockwave. Even though getting a net energy gain from nuclear fusion is a big deal, it's happening on a much smaller scale than what's needed to power electric grids and heat buildings. The big challenge of harnessing fusion energy is sustaining it long enough so that it can power electric grids and heating systems around the globe. Chittenden and Rollstone told CNN that scientists around the globe now must work toward dramatically scaling up their fusion projects, and also bring the cost down. Getting it commercially viable will take years of more research. At the moment we're spending a huge amount of time and money for every experiment we do, Chittenden said. We need to bring the cost down by a huge factor. However, Chittenden called this new chapter in nuclear fusion a true breakthrough moment, which is tremendously exciting. Rollstone said there's much shows more work needs to happen to make fusion able to generate electricity on a commercial scale. The opposing argument is that this result is miles away from actual energy gain required for the production of electricity, he said. Therefore, we can say, it is a success of the science but a long way from providing useful energy.